In this video, I'm gonna show you how to hack STP. Spanning Tree Protocol or STP is one of the most common LAN protocols deployed in today's enterprise networks. I'd recommend you to dive deeper into STP because it's really important and lack of securing it could disrupt your entire network. A very good resource for learning about STP is the Cisco CCNA course. This video assumes that you have some basic knowledge about how STP works. Let's recap in a nutshell what is its purpose and how it works. Redundant links are always welcome in switched topologies as they avoid the single point of failure issue of a single switch or link that fails. In the example you are looking at, if the link between switch A and switch B fails, the traffic from A to B will still reach the destination through root switch. However, redundant links, if we look at them from layer 2 perspective, can cause layer 2 loops which further can cause broadcast storms and multiple frame transmission. This is simply because there is no time to leave field in Ethernet header. For example, in this image, if host A sends a broadcast frame, that frame will be received doubled by host B. The first path is A, switch A, root, switch B, and host B, and the second path is host A, switch B, and host B. So host B will receive the broadcast frame 2 times. Fortunately, spanning tree can allow us to have redundant links while having a loop-free topology, thus preventing the potential for a broadcast storm. STP achieves this loop-free topology by selecting one switch as the root bridge, and the network administrator can influence which switch becomes the root bridge because this is the central part of the switch topology. Selecting a specific switch as the root bridge is done by manipulating a value called switch priority, and the switch with the lowest priority becomes the root bridge. If the root bridge goes down or another switch must become the root bridge, the STP topology must reconvert by electing a new root bridge, and the election starts at that precise moment. Switch ports do not immediately transit from the blocking state to the forwarding state. The ports go through some different states, and the time before the ports start to forward packets can be up to 1 minute. Okay. Now that we have a basic understanding of how STP works, let's see how a hacker could attack STP. In this lab, I'm gonna show you how to exploit the way STP works, and I mean the way STP elects the root bridge. This is another denial of service attack that is easy to be launched from a Linux machine using an application like Yersinia. It's the same application we've used for the CDP attack. Take a look there if you feel the need to see again what is Yersinia and how to install it on Linux. Taking over the root bridge is probably one of the most disruptive attacks. Keep in mind that STP is trustful, stateless, and does not provide an authentication mechanism. Running Yersinia from Kali Linux, I'll claim the root bridge role by sending BPDU frames with a lower priority than of the actual root bridge. For STP, a lower priority means a superior priority, and the switch with the lowest priority becomes the root bridge. Yersinia will take the role of a rogue switch. By the way, I've said BPDU frames. These are Ethernet frames used by STP for its operation. This attack is both of type denial of service and man in the middle. Denial of service because STP takes time to converge once a change in topology occurs, and during this phase, no data is forwarded by any switch in the network. The attacker could continuously reset the topology converging process before it has any chance to finish. The switch will be put in such a state that will continuously calculate the final STP topology. And man in the middle, because if the attacker inserts a rogue switch in the network and that switch becomes the root bridge, traffic could be diverted through the rogue switch. Okay, let's exploit STP. This is the topology I'm going to use. My laptop runs Windows 10 and Kali Linux in a VM. It's connected directly to a Cisco Catalyst switch using a wired Ethernet connection. If you use the same setup, don't forget to set the VM network in bridged mode so that the Linux machine has access to the physical interface of your laptop. To reproduce this attack, besides a Linux machine, you need a Cisco Layer 2 switch or any other switch that supports STP. You will connect the Linux machine to the switch using a wired connection. Now, if you don't have available such a physical switch, you can still launch the attack. Just run a Cisco L2 IOU in GNS3 and set up a network connection between the Linux host and the devices that run in GNS3. Take a look at the previous lecture where I have explained in detail how to do that. In this topology, notice that there are two redundant links between switch 1 and switch 2. This is what a redundant topology means, and STP will temporarily disable a port to avoid the problems of redundant layer 2 topologies. This is a console connection to switch 2. The default STP priority of a switch is 32,768. Let's check it. Show spanning tree. We notice the switch priority and that this switch is the root bridge. If you want to be sure that a particular switch becomes the root, just decrease the priority. You can set the bridge priority in increments of 4096. And I'm gonna set the priority to a lower value. conf-t, spanning tree VLAN 1, all ports belong to VLAN 1, priority, and the value. You cannot give any value, only in increments of 4096. For this example, the priority will be 28,672. And of course the switch is the root bridge of the topology. We see the message here. This bridge is the root. Back to Kali Linux, I'll start Yersinia as root. So Yersinia minus G, written in uppercase. Minus G option makes Yersinia to start a graphical session. I'll click on Launch Attack, and in STP tab, I'm selecting claiming the root role and then OK. Yersinia immediately starts sending BPDUs with a lower priority than the priority of the root bridge, claiming the root role. You can adjust the values in the BPDU frames here in this window. Okay, let's return to the switch and see if it's still the root. I'm executing show spanning tree command. And we notice that the switch is no more the root bridge. There is a cost of 19 to the root. Back to Kali Linux, I'll stop the attack. List attacks and stop. Show spanning tree again. The switch is still the root. I am waiting a few seconds. Okay, we see that the switch has become again the root of the topology. If we don't have or don't want to use the graphical interface of Yersinia, we can start the attack in command line, like this. Yersinia, STP, the name of the attack, and minus attack, and the ID of the attack. In this case is 4. Let's return to the switch and execute show spanning tree again. And we notice that the switch has lost the root role. Okay, I'm stopping Yersinia and the attack. You've just seen how to hack STP one of the most used switching protocols in enterprise networks. In the next lecture, I'll show you what countermeasures you can take to protect your switches against this attack.